You're welcome to Olusegun Mass Clinic. Today's class, we want to solve a question on resistor. And before we start solving the question, let me introduce myself. I am Olusegun Adelekun, a mathematics teacher and physics teacher. And this Facebook page, try help us to like and share our video or what we have been doing that you believe it is meaningful and good. Help us to share the video and also like. At the end of this video also, try to like this video and share if you really believe what we are doing is meaningful. So today's topic is resistance. It's the total sums of the resistor. What are the authorities? What are the things that you must know before getting the total resistance of this a very big circuit? You must understand some facts and figure that will give an authority that will make you to know that this is what you are going to do before adding them together. So let's try to back to the question. So you see these questions, it starts the electricity, the current will move from P. When it moves from P, it will come out from Q. So now, before we know that sums are parallel, sums are in series, it is the current that will determine what will make me to know that the resistor is in parallel or it's in series. So I will try to draw the resistance in this video. So don't skip this video. Try to watch it to the end. You might gain one or two things from it. Even though you are not an engineer, but still, there's some certain thing that you must, because it is everyday activities that we must able to learn from it. So let's try to analyze. So if the current is now moving, it will start from here. At this junction, the current will split. One will move like this, this another one will move like this. So because this is now moving in this form, because as this is a junction, you have to consider that junction. So this one moving here will also move to this extent. It will move to this. So now showing to us that the 2 3s, 2 2 2, they are in series. So this current moving like this, because they are not moving, they are not splitting anywhere. So now telling us that these 3 resistors, they are in series. So the sum of this, let's represent it by R total 1. So let's represent this by R total 1. And R total 1 will be the sums of 2 ohms plus 2 ohms plus 2 ohms. So now the R total 1 will now be 6 ohms. So telling us that the total resistance, because this total of this, because this is a junction, what now gave us the authority to know that these 3 ohms must be parallel to 6 ohms, because the current split at the junction. So the moment the current split at the junction, is mean the total of this must parallel to this. So let's now redraw. This diagram will now be equal to this diagram I want to draw. You see this diagram now. We have 1 ohms. It moves to the junctions. It moves like this. It moves like this. So this is PQ again. This is 1 ohms. So this is now the 3 ohms. So now this is the junction. I've been able to find the other time the R total 1. Now good. So the total of this now gives us 6 ohms. So it is this diagram that equal to this diagram now. So if this diagram is this circuit now is the same circuit as this in the board. So now, because now the 3 ohms have, because the current coming here we split into 2. Let's say the I1, it will give you I2. So another one will go like this, another one will also go in this form. So because at this junction the current split into 2, meaning that the 3 ohms is parallel to 6 ohms. So if the 3 ohms parallel to 6 ohms. Let's represent, so the total of these two, let's represent it by R total 2. So, because by representing this by R total 2, we now make us to have another diagram entirely to now get the total, the R total. So, if this is parallel to this, means that the formula is this: 1 over R total 2 is equal to 1 over 3 plus 1 over 6. So, let's find the LCM between 3 and 6. The lowest common multiple will give us 6. So, 3 in 6, we have 2, plus 6 in 6, we have 1, which is equal to 3 over 6. Can be written as 1 over 2. So, if 1 over R total 2 is equal to 1 over 2, let's try to cross multiply. So, R total 2 times 1 is equal to 2 times 1. So, R total 2 is equal to 2 ohms. So, telling us that the sums of these ohms here is 2 ohms. So, after, because they were parallel, so the addition of these two, the 3 ohms and 6, so because they are parallel, the total resistance is 2 ohms. So, this diagram will now going to be equal to another diagram now. So, let me just draw. So, it will now be equal to another diagram entirely, which will now give us something like this. So, what we are going to write here now is now the 2 ohms. So, can you now see that this diagram is equal to this diagram? So, now, to now get the total resistance overall, because the current will now move in series now. Let's try to re-explain better. You see, the current will now move in series. You see? So, it will move like this. When it reaches this junction, it's not going anywhere any longer. So, the current will also move like this. The current will continue. So, the current will also continue here. So, you're able to see that the current will now be moving around in series form. So, we are able to reduce the circuit to a series form. So, now the total resistance overall now of the whole diagram that we are able to draw will now give us that the R total, let me try to clean this. So, the R total will now be the 1 ohms plus 2 ohms plus 1 ohms. So, which will give us 4 ohms. So, telling us that, thank you. So, telling us that the total resistors that this circuit has is 4 ohms. So, these are the procedure. These are the steps. And these are the things that will make you to know that you are really getting what you are doing. Because you must be able to understand how the circuit, how the current is moving. The way the current is moving will determine how to know that the resistor is in parallel or it is in series. So don't forget to like this video, share this video, and also I really even appreciate you for watching and gaining more. Thanks.